On June 13th, 2018, a University of Maryland football player passed away due to overheating. Tasked with running 110-yard sprints, he kept pushing his body as it kept failing him. Instead of being thrown in an ice bath, he was rushed to the hospital, a critical and costly decision. Jordan McNair's death was preventable, and we believe that we are the solution that will prevent people from overheating in the future. We provide an active cooling mechanism for people as they are exercising. Using computer vision and machine learning, we are able to effectively target overheating areas through the combination of a thermal sensor and camera. This powerful combination can provide an accurate real-time heat map of the body, allowing people to see visual changes as they are working out.
Okay, this photo shows a general setup of our product. From this photo, we can easily find a Raspberry Pi end and an Arduino end. According to this, we can divide our system structure into two major parts. The first one is thermal imaging pipeline that contains the core hardware called Lupton 3 thermal camera sensor. The second part is the HVAC system for the hardware controlling. It controls the major hardware such as it controls the regular home use AC unit for the modification of the temperature. It also controls a pair of pan tilt for changing the angle of air blowing. It also controls a pair of damper for changing of the amount of air we provide during the cooling progress. In the next couple slides, we're about to dive into each part separately. I'm mainly responsible for the thermal imaging pipeline, and John is mainly responsible for the HVAC system. Okay, here goes to the thermal imaging pipeline. Before we go deep into the architecture, this is the core hardware, the Lupton 3 thermal camera sensor. This little device can not only provide an accurate measurement of body temperature, but also it can output a real-time heat map so that the users can actually know what is happening on their bodies while they are doing the regular exercise sessions. And now, this photo shows the circuit of thermal imaging pipeline. This part is built up for extract the temperature and the location of the user and output that as the data for the HVAC systems and electric algorithm. For building up the communication we discussed above, we need to start up two applications. The first one is the streamer server.c++ in Raspberry Pi. This server initiates the I2C commands and collects the frames from the Lupton and send it to the client. The second one is the streamer in user's local PC. This application connects to the streamer server through sockets and sends the FCC command and then collects the frames and analyzes them with the OpenCV. Once it finishes the analysis of all the data, it will package up all the information and send it to the HVAC system.
This is the HVAC unit hardware. Instead of using the regular remote for the AC, we transferred all of the functions into the air meter, which is controlled by an Arduino. This lets us control the AC by our PC. On this slide, on the left, we have our pan tilt, and on the right, we have our damper. This is the structure for the HVAC unit. Using the PID algorithm, this component allows us to output commands sent over the thermal imaging pipeline, as well as generate responses to the Raspberry Pi over serial. It allows the HVAC system to collect specific data such as body temperature and user position, which then gets sent to the pan tilt and damper. As we can see, Billy begins his workout. The data such as body temperature and position get sent to the HVAC unit, which then allows the pan tilt to start tracking motion. We also know that the protocol has been sent to the AC because it beeps every time when the AC unit changes temperature.
This is our user interface. We split our service into two windows. The first one is called Person Detection that contains the real-time infrared heat map with the function of SVM algorithm for the human detection. The second window is called Person Positioning. It shows the user's body temperature while tracking the motions with the blue pivot point.
The orange line represents Billy's workout without using the heat system. He worked out for 35 minutes. The blue line represents Billy's body temperature when he used the heat system. As we can see, there's a major difference as we were able to keep Billy's body cool when he was exercising. We can also see that his recovery time was faster after his workout. Ultimately, we hope to see our device implemented in gyms and on the NCAA level. We hope that by using our device, we are able to help people reach their fitness aspirations. Thank you.